For this section, we learn about Section 4.1, Introduction to Polynomials and Polynomial Functions. And you can look my notes. The definition for monomial, for polynomial, and example for each. For this case, for the example 2 on page 326, we going to evaluate these polynomials, okay? Alright, the question is, identify the terms, the degree of each term, the degrees of the polynomial, then identify the leading term, the leading coefficient, and the constant term. Again, I provide you definition for each term here. Let's see, we'll start off with term of a polynomial. Identify the terms, right? Now look at my note, or in the book, basically in the book, saying that the terms of a polynomial are separated by plus or subtract, plus or minus, right? Plus or minus. So this are terms. So you would say 6x squared is one term. Second term is ax squared y to the third power. Third term is negative, okay, don't forget. The reason I don't write the sign here, I mean plus. So this third term is negative 17xy. The fourth term is negative 24xy squared z to the fourth power. And let's see, 1, 2, 3, 4. So this is the fifth term right here. It's separated between plus and minus, okay? So, but it's more correctly, it's separated by the plus sign. Okay, so here we have plus 2y, the fifth term, and the last term is 3. Okay, so one term, second term, third term, fourth term, fifth term, and sixth terms. This is the answer right here. Okay, 4 terms. Alright, now we need to find the degree of the term. So you look at, let's see, degree of term is the sum of the exponents of the variables, if there are variables. Okay, look at this first term right here, 6x to the second power. The exponent is 2. So that's the degree of this term, which is 2. Okay, so 2 is the degree of this term. How about this second term? X variable has the exponent 2. Y variable has the exponent 3. So 2 plus 3 is 5. So the degree for this second term is 5. Okay? How about this term, the third term? X has exponent 1, right? Y has exponent 1. So 1 plus 1 is 2. So 2 is the exponent for this term. How about this term right here, negative 24 x raised to x times y squared times z to the fourth power. Now x has exponent of 1, right? So 1 plus 2, the exponent of y, plus 4, the exponent of z. We have 1 plus 2 is 3, 3 plus 4 is 7. So 7 is the exponent for this term, negative 24 xy squared times z to the fourth power. How about this term? 2y. It only have one variable, right? And the exponent is 1. So for this term 2y, the degree of this term 2y is 1. How about this term? Constant. This time is the term is a constant 3. So what is the exponent? Now you don't see it. It doesn't mean it doesn't have it. This, do you agree if I write 3 equal to 3, either x or y, doesn't matter, okay? X raised to 0. X raised to the 0 is 1, okay? 3 times 1 is 3. So that means the left-hand side to the right-hand side, which is true statement. Okay, so that means when you don't see it for a constant, it means it can be any variable, x or y. Okay, but both raised to 0, or either one of them. You can have x alone, or you can have y alone raised to 0, or you can have both raised to 0. Okay, 0 plus 0 is 0. Or when a k is alone, x raised to 0 is still 0. Okay, or in the k, y raised to 0, the exponent is still 0. So the degree of this term constant, right? The degree of the constant term 3 is 0. Okay? So 2 is the degree of 6x squared. 5 is the degree of term ax squared times y to the third power. 2 is the degree of negative 17 times xy. 7 is the degree of this term, negative 24 times xy squared times z to the fourth. 1 is the degree of this term, 2 times y. 0 is the degree of this constant term, 3. Alright, how about the degree of polynomial? Everything here is the polynomial, okay? Alright, let me rewrite this one. I just crossed that to this term is x, y squared, z to the fourth. Okay. The whole thing is a polynomial, okay? So what is the degree of the polynomial? Alright, you're not sure, look at my notes or the books. Degree of polynomial is the same as the degree of its term of highest degree. So which term is that have the largest exponent, largest degree? Degree of term, right? Which one? 252,710. 7 is the largest, right? So 7, let's say first, second, third, fourth. So 7 is the degree of the fourth term. So what's the fourth term? 1, 2, 3, 4. So this four terms right here has the highest degree. So the degree of polynomial is 7. Okay? Degree of polynomial is 7. It has the exponent, or the degree of the term that has the largest degree, the largest exponent. Alright, so 7. 7 is the degree of this polynomial. Leading term. What is leading term? So the leading term of a polynomial is the term of highest degree, is the term of the highest degree. So you know the highest degree is 7, right? Which is 1, 2, 3, 4, the fourth term. 1, 2, 3, 4, which is this term. So you would say the leading term, okay, which is this one, negative 24 x y squared z to the fourth power. Okay? So this is the leading term. How about leading coefficient? The leading coefficient, the coefficient of a leading term is called, let's see, the coefficient of the leading term is the leading coefficient. So look for the leading term, okay, and find the coefficient of the leading term. Coefficient is the value in front of the variables. So this is the leading term, right? You're looking for the coefficient of this leading term. What is the coefficient? It's in front of all the variables, which is negative 24, right? So negative 24 is the leading coefficient. Okay, so look for the leading term. For the leading term, look for the coefficients, any value in front of the variables. That value is the leading coefficient. How about constant term? Look at all the term right here. Which one constant? The last term, right? Which is 3. So this is how you solve this example. We identify the terms right here. We find the degree of each term right here, right? And we find the degree of the polynomial, which is here, and then identify the leading term, the leading coefficient, and the constant term.